Still on chapter 23, this is the fourth video in this segment, and this one's going to be on digestive processes in the stomach. So there are a number of processes carried out by the stomach. There's some obvious ones. It carries out the breakdown of food, it serves as a holding area, but it also delivers chyme to the small intestine, denatures proteins by hydrochloric acid, and pepsin carries out enzymatic digestion of proteins. Lipid-soluble alcohol and aspirin are absorbed into the blood. The only stomach function essential to life is the secretion of intrinsic factor for vitamin B12 absorption. And if you remember from chapter 17, vitamin B12 is necessary for red blood cells to mature. If an individual lacks intrinsic factor, it causes pernicious anemia, and it would be treated with vitamin B12 injections. Gastric mucosa secretes more than 3 liters of gastric juice a day, and it's regulated by neural mechanisms and hormonal mechanisms. So vagus nerve stimulation will increase secretion, sympathetic stimulation will decrease secretion, which makes sense if you remember from the sympathetic nervous system back from ANP1. Parasympathetic was rest and digest, and sympathetic is fight or flight, and so you don't really want to be digesting food if your sympathetic nervous system is active. And then we have the hormonal mechanisms. Gastrin stimulates hydrochloric secretion by the stomach, and gastrin antagonists hormones by small intestine. Gastric secretions are broken into 3 phases, and we're going to talk about each one of these individually. There's the cephalic phase, the gastric phase, and the intestinal phase. The cephalic phase is a conditioned reflex. It's going to be triggered by the smell, the taste, the sight, or even the thought of food. I don't know if you've ever pre-COVID been in class and you're hungry, it's late, and all you can think about is the leftover pizza that's in your refrigerator. That can actually cause gastric secretion. Then we have the gastric phase. This is going to last 3 to 4 hours. It's going to provide 2/3 of the gastric juices that's released. And then we're going to talk about the stimulation of the gastric phase. And this occurs with distension of the stomach. It's going to activate the stretch receptors. And then chemical stimuli, such as partially digested proteins, caffeine, and low acidity, activate enteroendocrine G cells to secrete gastrin. So once gastrin is released, it initiates hydrochloric acid release from the parietal cells and activates enzyme secretion. And the way that it helps to activate the parietal cells is by binding to the receptors on the parietal cells and stimulating enteroendocrine cells to release histamine. Now, excuse me, the buffering action of ingested proteins is going to cause the pH to rise. And what this means is the proteins literally start to act as buffers, and it removes some of the hydrogen ions, and that's going to cause pH to go up. And then that's going to activate more gastrin secretion. Low pH inhibits gastrin secretion. This is going to occur between meals and during digestion as a negative feedback mechanism. The more protein, the more hydrochloric acid is secreted, and this is going to decrease pH, which is going to inhibit gastrin secretion. And then we have the intestinal phase. This is going to begin with the brief stimulatory component followed by inhibition. Excuse me, I'm losing my voice. Stimulation of intestinal phase. So what occurs is partially digested food enters the small intestine, and this causes a brief release of intestinal gastrin. This is going to encourage the gastric glands of the stomach to continue secretory activities. However, the stimulatory effect is brief, and it's overridden by inhibitory stimuli as the intestine fills. So now we're going to talk about the inhibition of the intestinal phase. We have 4 main factors in the duodenum cause inhibition of gastric secretion. One is the distension of the duodenum due to the entry of chyme. Another is the presence of acidic chyme. Then we have the presence of fatty chyme and the presence of hypertonic chyme. And what these inhibitory effects do is protect the intestine from being overwhelmed by either too much chyme or acidity. Because keep in mind, the gastric secretions are very acidic, very low pH. And so if it just squirts a bunch of acidic chyme into the small intestine, that could damage the small intestine. And inhibition is achieved in two ways: the enterogastric reflex and the enterogastromes. Enterogastric reflex, the duodenum inhibits acid secretion in the stomach. In enterogastromes, the duodenal enteroendocrine cells release two important hormones that inhibit gastric secretion, and it's secretin and cholecystokinin. This is your question. And this is all I have for you for this talk.